Okay, welcome back, my dear students, to your sixth session. Uh, in this session, inshallah, we will talk about the trigonometry. Trigono- Trigonometry is a branch of mathematics. It's related to geometry, but it's especially talks about triangles and especially in the right angle triangle. In the right angle triangle. So we'll talk about, we have about four topics in trigonometry, four topics in trigonometry. Today, inshallah, we'll talk about the first topic. It's very, very easy. Okay, and tomorrow, inshallah, we'll work about the other. Okay, so we have to talk today about the trigonometric functions in the right triangles. Trigonometric functions in the right triangle. It's very easy. Okay, and inshallah, we'll talk about it quickly. We have to talk about first a right angle triangle. A right angle triangle, or when we talk about a triangle, when we talk about a triangle, the triangle has three types according to their angles. As we said, we have acute angle triangle, obtuse angle triangle, and right angle triangle. In the right angle triangle, we have one right angle and two acute angles. One right and two acutes. One right and two acutes, as you see. Okay, the side which opposite to the right, it's the longest side in the triangle, the longest side in the triangle, and it's equal to the hypotenuse. So what is the hypotenuse? The hypotenuse is the longest side in the right angle triangle and always is opposite to the right angle. And then after that, we have two acute angles. We have two acute angles. Each angle is opposite to one of the sides. Its angle, it's opposite to one of the sides. So we're going to get an angle or name an angle as angle theta. Angle theta. For example, this is angle theta. So this angle theta, so this is its opposite. This is its opposite side. And this is its adjacent side. So we have opposite side and you have adjacent side. Opposite side and adjacent side. Okay. We go about or talk about the main trigonometric functions or main trigonometric ratios. What are the main trigonometric functions or the main trigonometric ratios? Before main trigonometric functions or the main trigonometric ratios, if I said that this side, for example, equals to 4, and this side, which is adjacent, equals to 3. What about the hypotenuse? Huh? Can we get the hypotenuse? Can we get the hypotenuse? Wait. Can we get the hypotenuse? Recall with me how we can get the hypotenuse. The hypotenuse. The hypotenuse. Okay. Hypotenuse will be equals to wait. Wait. Hypotenuse equals to what? I have. No, Malak. Pay attention. Pay attention. It's a famous triangle. It's a famous triangle. It's equal to 5 directly. It's equal to 5 directly. So I have some famous, uh, or a special right triangles, which are 3, 4, 5. Multiply by 2. I multiply by 2, mister. It's 6, 8, 10. Multiply by 2. It's 12, 16, 20. Multiply the first by 3. So it's 9, 12, and 15. Mister, also we have 5, 12, and 13. All these are famous triangles. If I give you two sides, you can find the result. But mister, if we don't know, we will use the Pythagorean theorem. I don't know. I don't remember. This is 4 and this is 3. You ask me about the hypotenuse. So the hypotenuse will be the square root of the addition of 4 squared plus 3 squared. It means Mr. 16 plus 9. It means Mr. root 25. It means equal to 5. So you must get it, okay, even by using Pythagoras, or if you know the special cases. These are special cases. These are special cases, okay, for some famous triangle. You must know them. This is from GAT. This is from GAT. Okay, you must know them. 3, 4, 5, multiply by 2, multiply by 2, multiply by 3, and then after that we have the last one is a ordinary special case. It's 5, 12, 13. Because of course, if you have 13 power 2 equals to 12 power 2 plus 5 power 2, and 15 power 2 is equal to 12 power 2 plus 9 power 2, 20 power 2 equals to 16 power 2 plus 12 power 2, and so on. Okay, okay, it's complete. So this is, if he give me two sides in a right angle triangle, I can find the third side even by using the Pythagoras theorem or by using the famous triangles. Okay, mister. So we have to get the sine, the cosine, and the tan, the trig functions. We have three main trig functions, which are sine, cosine, tan. What is the sine? Sine is the ratio between the opposite and hypotenuse. Sine is the ratio between opposite and the hypotenuse. So I determine the angle. I get the opposite side over the hypotenuse. What is cosine? Cosine is adjacent over hypotenuse. What is tan? Tan is opposite over adjacent, or sine over cosine. It's a very important remark. Sine over cosine. Sine over cosine is equal to tan. Sine over cosine is equal to tan. Pay attention about this. So tan is opposite over adjacent, or sine over cosine, or sine over cosine. Okay, pay attention about this. Okay, we'll use it tomorrow, inshallah. The reciprocal identities. What is the reciprocal identities? Reciprocal, it means a flip. Okay, I'll flip. If you flip sine, it means 1 over sine equal 1 over sine equals cosec. 1 over sine equals cosec. 1 over sine equals cosec. 1 over cosine is equal to sec, is equal to sec. 1 over tan is equal to cotan. So these are called reciprocal identities. It means if the sine equal, for example, 3 over 5, what is cosec? 5 over 3. Just flip, just switch the fraction. Okay. So now we have 6 trigonometric functions. What are the 6 trigonometric functions, Mr.? I have sine, cosine, tan, their reciprocals, cosec, sec, and cotan. Pay attention with me. In the reciprocal, if we start by S, its reciprocal start by C. Always S with C. It can't be S with S or C with C. So sine, cosec, cosine, sec, in order not to confuse. In order not to confuse. Okay, okay. We're going to converting from degree measure to radian measure. Again, Mr. Again. To measure the angle, to measure any angle, we have two types of units. The first type is called the degree measure. The degree measure. And the second is called the radian measure. Okay. We can convert from degree to radian and from radian to degree. Pay attention with me, please. If we need to get the degree measure and we have the radian measure, if we want to get the degree measure and we have the radian measure, I'll take the radian measure. It means the theta rad. It means the radian measure. I'll take theta rad. It means the radian measure, and multiply it by 180 over pi. 180 over pi. Okay. And the opposite. If we need to get the radian and he gave me the degree measure, I'll take the degree measure, which is 45, 30, 60, and so on, and multiply it by the value of pi over 180. And leave pi as it is. Leave pi as it is. Don't calculate pi. Pi equals 3.14 meters. We don't calculate it, even if he need to calculate. Okay? Okay, so this is the way to convert between degrees to radian and from radian to degree. If we need to find the degree measure, I take the radian measure, multiply it by 180 over pi. The radian, multiply by pi over 180. Okay? Okay. We're going to the reference angle. What is the reference angle? The reference angle, it's very important. Pay attention with me. in this remark. If we talk and go about x-axis and y-axis, so x and y plane, divide the plane into four quadrants. The first quadrant, the second quadrant, here the third quadrant, and here the fourth one. In the first quadrant, in the first quadrant, you have the angle theta. Here we start from 0, and then 90, and then 180, and then 270, and we make a complete rotation and return back to 0, which is 360 complete rotation. Okay? Okay. If you have an angle theta in the first quad, so it's still theta. The angle is equal to 30. Okay. So theta is equal to 30. 60. Theta is equal to 60, and so on. But what about the second angle? Sorry, it's the second quad. In the second quad, the reference angle for any angle theta is theta equal 180 minus theta. So theta dash, it means the angle inside the second quad, 180 minus theta. But what about the third? The third will be theta minus 180. But what about the fourth? 360 minus theta, or negative theta, or negative theta. Okay, so in the first quad, we have theta as it is without any change. In the second quad, if you need to find the angle or the reference angle in an angle for the second quad, which is between 90 and 180, you will get 180 minus theta. It means, for example, if I ask you about an angle 120 in the second quad, mister, because it's in between 90 and 180. But what about the reference angle for 120? You just write 180 minus 120. 180 minus 120. Mister, it's equal to 60. So 120, it's related to 160. Sorry, 260. Okay? In the third quad, if we have 210, for example, what is the reference angle to 210? 210, you will make 210 minus 180. 210 minus 180 equals 30. So 210, it means 30. It means 30, but in the third quad. In the fourth quad, as we have, so 360 minus. So pay attention about this remark. It's not denoted here or not in the book. Pay attention. In the first quad, the values of sine, if you get a sine, a cosine, a tan for an angle in the first quad, it means sine 30, cosine 60, tan 45. All the values of sine, cosine, and tan will be positive. So if we get the sine, the cosine, the tan in the first quad, all will be positive. All will be positive. But in the second quad, what is positive, mister? The positive is only the sine and its reciprocal. So sine and cosec. So here all are positive. Here the sine is positive. The sine and its reciprocal. But in the third quad, what is a positive, mister? The positive value for the tan. If you get tan, tan will be positive. But if we get the cosine, negative. The sine, negative. But we have in the fourth quad, it's a cosine. So cosine is the positive. And this rule is called asterisk rule. A refers to or tends to all. And then S, it means the sign is positive. And then tan. And then cosine. So this is called asterisk rule, or sine, tan, cosine. So all are positive in the first quad, sine and its reciprocal in the second quad, in the third quad, tan and its reciprocal in the fourth quad, cosine and its reciprocal. Pay attention about this. Pay attention about this. Okay. We're going to the length of the arc. The length of the arc. The last part in our lesson. What is the length of the arc? Mister, we talk about it in geometry. Do you remember? Just recall. S or L. Who remember? Yes, excellent. It's the central angle over 360 multiplied by the circumference of the circle. This is what? This is the length of what? The length of what? The length of the arc. Arc is a part of the circumference. But we have another rule. And I talk about it. I'll talk about it again. So S or L equal if we work with a radian measure. يا مستر انت واضح جدا انك هنا شغال بديجري measure because you get the degree measure over the total angle 360 multiply the circumference. Here, just if you have the radian measure, just to get the radius length, just to get the radius length, okay? And then after that, multiply it by the angle. But the angle must be radian. So theta rad. So R multiplied theta rad. R multiplied theta rad. So if the angle is radian, it's easy. It's more easy. I get the radius and multiply it by the angle. If the angle is a central angle, it means in degree, we use the other rule in the other side. Okay? Okay. Let's start our problems. Suppose that an angle, theta is an angle and in its standard position, such that cosine theta is greater than 1. Cosine theta is greater than, sorry, 0. It means positive, mister. So, Mr. Cosine theta is positive. So I just write cosine is positive. Which quadrant the terminal side of the angle lie? Oh, you just said, Mr. Cosine is positive. In which quad? You said in the first quad, all are positive. So in the first quad, in the first quad. So the second and third is out. In the first and the second, or first and third, or first or the fourth. Yes. So it's what? Fourth only? No, first and the fourth. First and the fourth. So the answer is letter D. As you said, the asterisk rule. All sine tan cosine. So asterisk rule. So the first and the fourth. Okay? Okay. We're going to number 2. What is the exact value for sine theta if cosine theta equal negative 3 over 5 and we work in the second quad or the second quadrant. From where, Mister, you know that you work in the second quadrant? From here. Pay attention. Theta is included between 90 and 180. So in the second quad. So I need to find the value of the sine. I need to find value of the sine. I need to find the value of the sine equals to what? The value of the sine equals to what? Huh? Who can answer? The value of the sine. Waiting. Okay, I know it's a sine. I need the sine. I need the sine. What is the sine theta if the cosine is كذا? Okay, pay attention, pay attention, pay attention. We have two ways to solve this problem. We have two ways to solve this problem, but we will talk about the common way. Just draw like this. Okay. Sorry, I can use the lines in order to get its organized. So I'm just, we have X and Y plane, and then just write here. Cosine theta is negative 3 over 5. So pay attention. Work in the second quad. Cosine is what? Cosine is what? Cosine is what? So this is theta. So I just write like this. Okay. So this is theta. We have here to write or to draw the so we have here this is theta, for example. Okay, so we have to draw the line, to draw a triangle. مستر يعني لما نشتغل هنا draw a triangle. طب مستر you have to write this. No, no need, just draw a triangle. Name any angle as theta. Yes. And this is 90. Mister, you said cosine is what? Cosine theta. Cosine is adjacent over hypotenuse. This is the adjacent and this is the hypotenuse. Mister, but we have negative. Don't talk now about the negative. Leave the negative now. Leave the negative now. We're going to get this is 3 and this 5. What is the third side? What is the third side? Who can give me the third side? Oh, it's a 4, a famous triangle. So no need to waste your time. The famous triangles are very, very important. Okay, if you don't know and use your Pythagorean theorem, it takes about 30 or 20 seconds. But now, just for Mr. Mister, you need to find the sign. You need to find the sign. Excellent. It's what? It's 4 over 5. So I just write 4 over 5. Mister, why it's not negative? Because in the second quad, sign is positive. All the other is negative. So if you get the tan, tan is negative. If you get the cosine, oh, the cosine is negative. He gave me the cosine already is negative. Okay, so the result will be 4 over 5. So I think it's easy now. I think it's easy now. He gave me one of the trig functions and asked me about another trig function. So you just draw a right angle triangle and write one of the acute angles as theta. And then after that, work like what we did. We're going to number 3. In number 3 is the same. In number 3 is the same. In number 3 is the same. طب يلا نحل number 3 دايركتلي كده يا مستر على طول اهو. Yes. Okay. I have here 90 degree. I have here theta. Okay. And B is an acute angle triangle. ماشي. B equals to what? B equals sine B. Means opposite mister is equal to 5. And the hypotenuse excellent is equal to 13. What about the third side? What about the third side? Yes, it's 12. Famous triangle. Directly, in 1 second. In 1 second. No need to waste your time to make 13 power 2, 169. And then after that, 5 power 2 is equal to 25. And make minus. And then after that, you find 144 underscore. What about all this? Directly, you have here 12. Okay. And then he asked me about what, mister? He asked me about tan. He asked me about tan. Pay attention about one of the most important remarks when we read the problem. Angle B is an acute angle. Acute angle, it means in the first quad. So all are positive. Okay, so we don't care about a negative sign or all are positive. Okay, mister, find the value of tan B. Tan equals what? I name it by theta. It's theta B. There is no problem. Tan is opposite over adjacent. Opposite over adjacent, it means 5 over 12. It's very easy. Okay. We're going to, we're going to, we're going to number 4. But before number 4, I'm going to get or going to number first. Number 5, number 6, number 7, number 8, number 9, number 10, and return to number 4 at the end of the session. Okay, number 5. Find the exact value of 100 and cosine 135. Cosine 135. Cosine 135. So I'm going to relate here cosine 145. Okay. So pay attention with me. Pay attention with me. Okay, pay attention with me here. Pay attention with me here. Pay attention with me here. Here or at the beginning, we have some famous triangles. These famous triangles related to know the sine and the cosine and tan for some famous angles. These are the angles. Pay attention with me, please. You must know this. You must know this. Pay attention. The sine, the sine, the sine. Also, as the famous triangles, you must know the sine of 30. sine 45, sine 60, sine 90, sine 180, sine 0, sine 360. Again, this also will be very important for cosine. Will be very important to tan. Pay attention. If I said sine 30, it's half. Sine 45, root 2 over 2. Sine 60, it's root 3 over 2. Sine 90, it's 1. Sine 180, it's 0. Sine 0 is 0. Okay? This is for sine. Mister, we must know this? Yes, because you don't have a calculator. If I said sine 30, you don't have a calculator to write sine 30. Sine 30 is equal to half directly. Sine 60, root 3 over 2. Sine 45 is root 2 over 2. Sine 90 is 1. Sine 180 or 360 or 0 is equal to 0. What about cosine? The opposite. خلي بالك هنا كده، بص الاوبوزيت. انت ايه؟ انت قلت هنا 30. طب ال 30 كانت وات هاف. هتلاقي الهاف هنا اتنقلت مع ال 60 عند الكوساين. وال 3 روت 3 اوفر 2 اتنقلت مع الكوساين. يعني لو قلت لك كوساين 30 روت 3 اوفر 2، كوساين 60 equal to half، كوساين 45 the same، cosine 45 the same. Sine here equal the cosine in the angle of 45. Cosine 90 is 0. Cosine 180 is negative 1. Cosine 360 or 0 is equal to 1. What about tan? Tan 30 is 1 over root 3. 1 over root 3 or root 3 over 3. It's the same, but this is the simplest form. 3 over root 3 is the simplest form. What is sine 45? Is equal to 1. What is sine 60? Is root 3. What is sine 90? Sine 90 is undefined. عشان كده هو حاطط لك cross sign. يبقى sine 90 is undefined. Sine 90 is undefined. Okay, sine 100, sorry, tan 90. Tan 90, sorry, tan 90. Tan 90 is undefined. Tan 90 is undefined. And then after that, tan 180 is 0, and tan 0 or 360 is equal to 0. Pay attention about this. You must know them. You must know them. Without them, you can't enter to the exam, because we have sine, cosine, and tan always in the exam. How we can work without these angles? Mister, if he give me an angle, for example, an angle 25 or an angle 55, he don't give you an angles like this. He give you only these angles, the famous angles, the famous angles. Okay? Okay. So let's return back to our problems. Return back to our problems, to problem number 5. Find the exact value of cosine 35. Cosine 35, how can I find it, Mister, without calculator? It's very easy. First, this angle 35 in which quad? The second quad. Okay, excellent. So it's the second quad. And you said in the second quad, I get the reference point as 180 minus theta. It means, Mr. 180 minus 135. So the result will be, if you, yes, without calculator, it's a 45. Okay, so it's a 45. So we deal with 45. It means, Mr., it's now cosine 45. Cosine 45 equals to what? Yes, Mister, I remember it. It's root 2 over 2. From what? From the table inside. From the table. Root 2 over 2. But, pay attention. In the second quad, you said, Mister, in the second quad. In the second quad, yes, in the second quad, cosine is negative, because only the positive is what? Sine. According to what? Aztec rule. So it's a negative root 2 over 2. I think it's very easy. I get the result without the calculator. Okay. We're going to number 6. The same. What is the exact value for sine 240? from the beginning ركز كده معايا. Pay attention please, focus. انا هشتغل هنا في الثيرد كواد. في الثيرد كواد tan only is positive. Tan only is positive. So the result must be negative. So I ignore this and I ignore this. From the beginning. Okay. I'm going to get the reference angle. Mr. In the third quad, it will be the angle, which is 240 minus 180. So, Mr., it will be equals 260. So, Mr., I need to find the sine 60. Sine 60 is equal to, yes, equals to root 3 over 2. But, Mr., it's negative, so it's letter A. It's negative, so it's letter A. So, Mister, pay attention, pay attention, pay attention, pay attention, pay attention. I saw a mistake. Pay attention. The reference point again in the first quad, it's theta. The second quad, 180 minus theta. In the third quad, don't say 270. Theta minus 180. We don't use 270 and 90. We use 180 only. In the second, 180 minus. In the third, the angle minus 180. Okay, okay. And in the third quad, fourth quad, we use 360 minus. So it's equal to 60. If you use the other way, it will be 30, and the whole problem would be wrong because you will choose letter B. Okay, because it's sine 30, Mr. Sine 30 is equal to half, so it's negative half. I get the full mark. You get super zero. So pay attention about this. Okay, pay attention about this. Okay. We going to complete. Going to complete number 7. The reference angle for the angle 150. It's very easy. What? 150? Yes. In which quad? In the second quad. In the second quad, 180 minus theta, 180 minus 150 equals to? Yes, equals to 30. We're going to number 8. Find the degree measure. Oh, give me a radian measure and ask me about the degree. I need to find the degree measure. So I just take the radian measure 3 pi over 2 multiplied by 180 over pi. As I said, cancel pi with pi. Divide by 2 equal 1. 180 divided by 2 equals 90. 90 times 3 is 270. So the result is 270. Again, Mister, I need to get the degree measure if the radian measure is equal to 3 pi over 2. Just write 3 pi over 2 multiplied by 180 over pi. The opposite is number 9. The opposite is number 9. I have an angle 60 and I read it's radian. So I just need theta rad. So theta rad is equal to theta degree, which is 60, multiplied by the opposite, pi over 180. Cancel 0 with 0. Divide by 6 equal 1. Divide by 6 equal 3. Mister, it's pi over 3. Pi over 3, or in some choices, it will be 1 over 3 pi. It's the same. So pi over 3. Okay. We're going to number 10. Number 10, the length of the arc. Oh, the length of the arc. Mister, you said the length of the arc with the radius 7 centimeter. He gave me the radius, and the measure of the angle of its sector is 90. The angle is 90. Okay, so I have two ways. I can use this first way or the second way. It's up to you. I get the length as 90 over 360 times the circumference 2 times pi, okay, times r, which is 7. Mr. Pi is 22 over 7, we said before, but I cancel. Divide by 90 equal 1, divide by 90 equal 4. So, Mr., it's 1 over 4. Multiply by 2. Multiply by 22 over 7, which is pi, 22 over 7 and 3.14. Cancel now, Mr. So the result will be 22 times 2 and all divided by 4. 22 times 2 is 44 divided by 4. It's equal to 11. We get the result. Okay. We have a small remark, but it's very important. It's related only to number 4. But just pay attention about it. We're going to talk about identities. I'm going to check if it's in the no. Okay, the identities. What is the identities? What is the identities? Pay attention with me, please. The first identity and the most important identity, it's called sine square theta plus cosine square theta. It's equal to 1. This is coming from what? Coming from Pythagorean theorem. And you must know it. Sine squared plus cosine squared equal to 1. Yes, it's exact. It's a rule. From this rule, we can extend 4 other rules. What are the 4 other rules? I can get cosine in the other side by the opposite side. So, so sine square theta will be equals to 1 minus cosine square theta. So, if we have to find sine, just remove 1 minus cosine squared. If I remove 1 minus cosine squared by what? By sine squared. And the opposite is right. Cosine square theta equal 1 minus sine square theta. Okay? Okay. And by this rule, we can solve number 4. We can solve number 4. Sorry, number 4 is not here. Number 4, number 4, number 4, number 4, number 4, number 4. Which of the following equivalent to the expression of the opposite expression? Pay attention. ركز معايا. مستر انت قلت لي لو لقيت 1 minus sine squared it's equal to cosine squared. 1 minus cosine it's equal to sine. So Mr. This expression I have sine theta up, so I just write cosine theta as it is, and down I have 1 minus cosine squared. 1 minus cosine squared, it's what? It's what? It's yes, excellent. It's equal to cosine squared theta. Okay. I'll divide cosine, divide by cosine equal 1, divide by cosine, I remove the power. So it's equal 1 over cosine. 1 over cosine, it's the reciprocal of cosine is what? Mr. C, it's S. So 6. So the result will be 6. You understand? It's very easy if we know the rule. It's very easy if we know the. Okay. So this is the end of our session. It's the end of the first session in trigonometry. Trigonometry is very easy if we know some special cases, some special triangles, some special or terminal angles, means the reference angles. Okay, if we talk about the quad, you must know the asterisk rule and so on. Okay, inshallah, you will find the videos on the group after 1.5 hours from now. And tomorrow, don't forget to make a just revision. Coming tomorrow, inshallah, from the school, going to sleep for 45 minutes or 1 hour. And then after that, you can revise. Revise what? Revise the videos, revise the exercises. And inshallah, we will work together in a small exam in geometry tomorrow. Thanks for your attendance. Thanks for your attendance, and see you.